Okay. First off, again, hopefully review. Hopefully you've seen this before. Two non-vertical lines in a coordinate plane are parallel. Make sure you know that they're parallel if they have the same slopes. Slope is how slanted a line is. If two lines are parallel, then they're slanted the same, so therefore they have the same slope. Two lines are perpendicular. Here's the rule that they give. That's not exactly the way that we wrote the rule in geometry. Two lines are perpendicular if the product of their slopes is -1. The way that we did it was two lines are perpendicular if their slopes are opposite reciprocals. So a positive 2/3 and a negative 3/2 would be opposite reciprocal slopes. -4 and a positive 1/4. Those would be perpendicular slopes. And if you want to test it, if you multiply them, you do get -1. Okay, it's the same thing. Also, a reminder from yesterday, if you're looking for the equation of a line, there's two methods of doing it. If you haven't already got these on your formula cards, you can use the point slope form. Y minus y1 equals m times x minus x1, or you can use your slope intercept, y equals mx plus b. Whichever method you want to use, go for it. First problem says, find the equation in slope intercept form of the line that passes through the point 1, -4, and that is parallel to y equals 3x plus 2. If two lines are parallel, they have the same slope. We're looking for a line parallel to this line. All the information we need from that is we're looking for a line. My line will have a slope of 3. That's all that says. If it is parallel to this line, that's the only relationship. Okay? Y-intercept here, this part, and this is the number one mistake people make, this plus 2 matters none. Okay? That plus 2 has absolutely nothing to do with this problem. The line that I'm looking for must be parallel to this. It doesn't say anything about being the same line as this, but it must be parallel to this so it will have the same slope. Also, I want my line to pass through the point 1, -4. These problems are identical to the problems we just worked. There is absolutely no difference. They give you a slope, they give you a point, find the equation. That's all you're doing there. Again, here's your review from yesterday. I'll actually work it both ways. Y minus y1 equals m times x minus x1. Lydia, help me plug everything in. Here's my point. That's my xy. Here's my m. So I have y minus what? It'll actually be y plus 4, won't it? Because it's minus minus equals. Go ahead. Times x minus. Everybody understand how you plug that in? Clean it up. Work it out. You're finished. Y plus 4 equals distributive property 3x minus 3. Plus 4 turns into minus 4. Debt, bigger debt, y equals 3x minus 7. Again, we were looking for the line parallel to 3x plus 2. That one is obviously parallel because they have the same slope. We wanted our line to pass through the point 1, -4, which means if you plugged in for 1 for x, you should get -4 for y. 3 times 1 is 3, minus 7 gives you -4. The other way of working that, pick which way you like best. Y equals mx plus b. You have your slope already. We obtained our slope from this. We want it to be parallel. That gives you half your answer, y equals 3x. And we're looking for the rest of the answer. We don't know our plus b. The way that we find our plus b, take this point, plug it in for x and y. That gives me -4 equals 3 times 1. Still don't know our plus b. Take this 3, move it over here by doing minus 3. And that tells me my b is -7. Go back and plug it in. Same answer. Next problem says, find the equation of a line perpendicular. This goes back to what you did for a warm-up today. I don't know the slope of this. Please don't say it's 3. Okay, this is not in slope-intercept form. Y is not by itself. Within 2 steps, or if you know the whole A over B rule and all that, that's fine as well. Okay, but within 2 steps, I can get my slope. Move 3x over, divide by -4. You have -4y equals 3x becomes -3x. When you divide by -4, there's your slope right there. Some of you will be able to do it in your head. That's fine. So my slope, that's all I need from this first problem. I'm looking for the line perpendicular to this line. This line has a slope of 3/4. Everybody sees that. From what I told you a while ago, Avery, if I'm looking for a line perpendicular to that, what will my line have a slope of? -4/3. Opposite reciprocals. +3/4, -4/3. And I want my line to pass through this point, -2, 1. Just to show you, this is not the line I'm looking for. If you plug -2 in for x and you plug in 1 for y, you're not going to get 8. You're actually going to get -6 minus 4, which is -10. Okay, this is not your equation. This will actually probably be your start of your equation. This 3x minus 4y. It just won't be equals 8. So here we go. Y equals, I'm going to try a shortcut way, -4/3 x blank plus b. I don't know the b. Plug in the x, plug in the y. Hopefully you're getting to the point to where you can do that, this multiplication without having to write it down. Your y is 1. -4/3 times -2 would be a +8/3 blank plus b. I don't know what my b is. Common denominator, 1 is the same thing as 3/3. Subtract 8/3, 3/3 minus 8/3 when you move it over gives you, anybody? Negative, thank you, 5/3. So y equals -4/3 x minus 5/3. Feel free to use point slope if you'd like to. Next problem says, given a rhombus with the given vertices, and I've plotted those, prove that the diagonals of the rhombus are perpendicular. We can't go by looks here. So what we're going to do is to prove that these diagonals, here's my rhombus. I'm not even going to draw it. I'm concerned about the diagonals of the rhombus. And this is actually one of your theorems from geometry, that if you have a rhombus, the diagonals will always be perpendicular. The way that we're going to prove that, we're going to find the slope of each line. One of my diagonals goes from 0, 0 to 8, 4. My other diagonal goes from 5, 0 to 3, 4. And let's do that in our head. Here's your formula for slope. Again, if you don't have it written down, y2 minus y1 over x2 minus x1. The second y minus the first y. Elizabeth, do the red ones for me. The second y, here's my 2 red points, my second y minus my first y. What do you get? Good. So 4 over the second x minus my first x gives me 8. Reduce it, we get 1/2. The slope, and we can see that. Rise 1, run 2. Rise 1, run 2. I could have done it that way as well since I have a graph. My blue line, or my blue points. Brianna, y2 minus y1, what do you get? Oh, -1 final answer. Oh, 4 over, thank you, which gives me a -2. So the slope of this line, -2. And since +1/2 and -2/1 are opposite reciprocals, those diagonals are perpendicular. That's what you would have to do to prove it. Find the slopes of each. Since diagonals are opposite reciprocals, those slopes are perpendicular. One more linear problem, and here you see a word problem, and this is a scenario that you get a lot as far as linear equations. From ABC Wireless, you have a monthly cost for your cell phone with 100 minutes per month. Here's your monthly cost. Or you can do 200 minutes per month for $45. Hang on, let me read that again. Read it too fast. From ABC Wireless, the monthly cost for a cell phone with 100 minutes per month is $35, or 200 minutes per month is $45. The cost in dollars is a linear function. Find the formula for the cost C. So here's your two scenarios. First off, when you're dealing with problems like this, think about what your input and your output is. 100 minutes is $35. You're putting in 100 minutes, you're getting 35. 200 minutes is going to cost you $45. And the question is, what if it's 400 minutes? You know, what's going to be the cost there? What we're going to do is we're going to try to find an equation. Okay, that way we can plug in any type minutes. You know, what if I use 600 minutes, 700 minutes? What's going to be my cost? Here's how we're going to do it. Create 2 points. When my input is 100, and our inputs again is going to be our minutes, our output is going to be our cost. So our X is minutes, our Y is cost. When we input 200 minutes, our cost is $45. And by the way, there's an easier way of doing this. You can honestly, hopefully you can look at that and tell how much you're paying per minute. Could you? You have 100 extra minutes and it costs you $10 extra. You see, you could just divide that and that would give you your minutes. Well, that's what slope is. From here forward, slope, guys, is a rate of change. I know slope is how slanted your line is, but slope is also a rate. And when I say rate, examples of rates, speed is a rate. Dollars per month, like this, is a rate. Inches per year, I don't know where that came from. If you want to know how fast you're growing, inches per year would be a rate. Okay, all those are examples of rates. So here, let's find our slope. I want to take and I want to find the equation of the line that passes through these 2 points, and that equation is our relationship between our cost and our minutes. Our slope, y2 minus y1 is 10. x2 minus x1 is 100. If you reduce that, you get 1/10. And you don't have to write this, but 1/10, by the way, is the same thing as 0.01. That's how you're more used to seeing this rate. No, it ain't. My bad. I should have corrected me there. 0.10. A tenth, that's 0.10, right? 10 cents a minute. Or, yeah, 10 cents a minute is what you're being charged. Let's actually leave it like that, just for, so we got y equals. To find the other part of our equation, we do the exact same thing. We plug in one or the other. Let's plug in this point. 0.10 times my x equals my y, so let's plug that in. Gives me 35 equals 0.10 times 100. I believe that would be 10. Blank. What goes in blank? Plus 10 plus what is 35? Good. There's the relationship. Let's interpret that in real world terms. X, your input, is your minutes. Y, your output, is your cost. 0.10 times x plus 25. Somebody translate for me in layman's terms. When you get your bill, what is that plus 25? And what is the 0.10? Anybody tell me? If you use 0 minutes, here's a thought. If you use 0 minutes, how much will your bill be that month? $25. So what is the $25? It's just a monthly cost. Okay. If you're paying per minute here, this 25 minutes is simply, whether you use your phone or not, you're going to pay $25. Does that make sense? And this 0.10 is a rate of change. Okay, this 0.10 is how much you're paying per minute. You use 1 minute, you're going to pay $25 plus 10 cents. 2 minutes, $25 plus 20 cents, and so on and so forth. Okay. This is extra information, but most of the time cell phone companies will also do this to you. Did y'all see this in Algebra 2? It's called a rounding up function. So if you use 1.1, you know what this ceiling function does? It changes the 1.1 to a 2. Rounding up function takes your number and rounds it up to the next whole number. And most of the time, if you're paying by the minute, if you use anything over 1 minute, it's going to bump it up to 2 minutes. If you use anything over 2 minutes, it's going to bump it up to 3, and so on and so forth. So that's what that does. But here's your equation. So, and notice they said find the formula for C. Instead of C, I put Y, where Y is the cost and X is the minutes. What is the cost of 400 minutes? Somebody that's got a calculator, please type that in for me. You're paying 10 cents per minute, so 400 minutes plus 25. How much will 400 minutes cost? What did you get? $65. everybody else get that too. Right. Thank you. Okay, next objective. Students will solve quadratic equations by using square roots, factoring, completing the square, and the quadratic formula. They will also evaluate the discriminant of a quadratic expression, also ACT. Everything we've done thus far is ACT material. Solving quadratics with square roots. And this book is set up a little weird. Let me tell you something. We've actually kind of already done this. They force you to sometimes use this in chapter P or chapter 1, whatever you want to call it, and then they don't teach it till the next chapter. And I've tried to figure out ways to get around teaching it in this order, but I can't really do it. Okay, x squared minus 9. We're going to start out solving these with the most basic steps. Okay, notice something about this. Let's review quadratic. 3x squared plus 4x minus 5. We factored quadratics back in chapter P. When you're factoring quadratics, most of the time you have an x squared term, an x term, and a number term. The problems we're going to start out working today is missing this x term. When you're missing this x term, these problems are extremely easy. Okay, pretty much 2 steps. Step number 1, move the 9 over. So you now have x squared equals 9. Step number 2, Jordan, how can I get rid of that square? What do I do to the other side? Square root. When you square root, this is the part people forget. When you square root, don't forget your plus or minus sign. Because technically, your answer could be positive 3 or negative 3, because look back at the original. Positive 3 squared is 9, also negative 3 squared, 9. Done. Get the x squared stuff by itself, square root, finished. Another one. Now here, it's going to be hard to get x squared by itself. You've got this whole thing being squared. First step, go ahead and get rid of the squared. To get rid of the squared, come to the other side and do plus and minus the square root of 0. Square root of 0 is 0. Do I need to put positive 0 or negative 0? I wouldn't. 0 is neither positive nor negative. You don't need that symbol on it. Last step, to get rid of minus 1, move it over. Turned into plus 1. And to get rid of 2, divide by 2. One answer. I also want to remind you, while you're writing that down, any of these can be solved with a graphing calculator. Any equation from here on out can be solved with a graphing calculator. We're looking for, if you graph this, we're looking for where is this equal to 0. A reminder from what I told you yesterday, y equals 0 is the x-axis. So we're looking for where does this cross the x-axis. Don't you normally have 2 answers? Whoops. You have a parabola, x-axis. Most of the time on these quadratics, like on that last problem, positive and negative 3, most of the time when you're dealing with quadratics, you will have 2 answers. Why does this only have 1 answer? Any theories? How about that? Because it only touches at one. And that should make sense to you, why it just has the single answer. Your parabola comes down, it touches at 1/2, and it goes back up. It doesn't cross, it touches. Okay. We'll talk more about that later. 2x squared minus 1 equals 0. Also should have 2 answers. Notice we don't have that x term again. Move the 1 over, move the 2 over, take the square root. I'm going to do that real fast in my head. Minus 1 becomes plus 1. Since the 2 is being multiplied, let's divide it. That gives you x squared is 1/2. To get rid of a square, square root. So you have plus and minus the square root of 1/2. Which is an acceptable answer. But I want to go a step further. The square root of 1/2 can be split into the square root of 1 over the square root of 2, which is 1 over root 2. We don't like radicals on bottom. I'm doing this to get you ready for trig. We do a ton of this in trig. To get a radical off bottom, I multiply top and bottom by some radical. That will remove it. And I now have x equals plus and minus. 1 times square root of 2 is the square root of 2. Square root of 2 times square root of 2 is 2. Either answer is acceptable. I like the bottom one better. This also good review. Look at this problem and see if you can picture what's about to happen. We want to get the squared stuff isolated first. The way that we're going to do that, we're going to take that plus 8, move it to the other side. Problem. Stuff squared equals negative 8. It reminds me of this type problem. Remember when we did absolute value? And when the absolute value was equal to negative 8, we automatically said no solution. There was no solution. If you square something, you're not going to get a negative, correct? Kind of correct. If you square a real number, yes, you will never get a negative. So that automatically tells us our answer here is going to be imaginary. Don't forget anything you learned in chapter 1. It comes back, I promise. So what we've got to do to get rid of a square, we square root. Leaves me with x minus 3 equals positive or negative root negative 8. Go ahead and move the 3 over, then we'll clean it up. So x equals 3 plus or minus root negative 8. Let's come over to the side, the square root of negative 8. Let's go ahead and get the negative 1 out of it first. We're left with a root 8. Allie, the square root of 8. What can I split the square root of 8 into? Do you see any perfect roots in 8? 2 and 4, good job. Everybody's sneezing up a storm. So I've split up the square root of negative 8 into the square root of negative 1, square root of 2, square root of 4. So that gives me final answer of 3 plus or minus. Square root of 4 is 2. Square root of negative 1 is I. Square root of 2, I have no idea what it is. Actually, I think it's 1.414, but that's beside the point. So there's your two answers. 3 plus 2i root 2, 3 minus 2i root 2. So you could have imaginary roots on this. Since my roots are imaginary, where does my parabola cross the x-axis? It doesn't. When you have imaginary roots, this is my x-y axis. This is my real axis. Okay? I don't have an imaginary axis here. If you have an imaginary answer, your your parabola will not cross the x-axis. Your second method for solving quadratic equations is by factoring, and we're also going to use what's called the zero product property. If two numbers multiply to give you 0, I've got a number in each hand. When I multiply those two numbers, I get 0. Anytime you multiply to give you 0, that means that one of those two numbers must be 0. There's absolutely no other way of getting a 0. You can't multiply 5 times some number other than 0 to give you 0. You can't multiply 1/4 times anything other than 0 to give you 0. Two things multiply to give you 0, one must be 0. Right. First problem. Now when you solve these, notice this is quadratic. We have all three pieces. It's equal to 0. Step number 1, factor. Hopefully we know how to factor. We did it in chapter P. X times x gives you x squared. Anna Marie, what adds to give me negative 1 multiplies to give me negative 12. Help me with that part. Close. 50-50. X minus 4 times x plus 3. If you add those two things together, you will get negative 1. If you multiply them, you do get negative 12. Everybody good there? Reminder of what I just said. If two things multiply, does everybody see these two things are being multiplied now? That's what factoring does. Factoring takes a sum and it breaks it apart into products. Two things multiply to equal to 0. The guy on that video that we were going to watch, he says, he calls it the T method. He breaks it apart now. He says that either x minus 4 has to be 0 or x plus 3 has to be 0. Solve each of them, you get x equals 4. And you get x equals negative 3. Looking at the graph of this, x squared minus x minus 12. We're looking for where it's crossing the x-axis. What I'm showing you guys, this is huge. Okay, please know the relationship. This is a parabola. We will know where it's equal to 0. Here's my parabola. Okay, comes down. It's equal to 0. Here's my 0. That's y equals 0. It's equal to 0 here. And it's equal to 0 here, which corresponds with the -3 and the +4. If you can't tell, you can't really read the tick marks, I think it might be -2.9. Again, here's how you do it. Second calc. You have a 0 function, 2. Left bound, right bound. This answer is somewhere between -5 and 0. That's what I'm looking for. So left bound is -5. Right bound 0. I don't have to guess. -3, 0. That gives you that answer. And if you wanted the other answer, you would have to go through that process again. So every graphing calculator you can use to solve any equation that you run up on. Okay, another one? Okay. I said if two things multiply to give you 0, one of those two things must be 0. What if two things multiply to give you 8? You ever thought about that? We always make you set it equal to 0. Why? Okay, let's go through all the scenarios. If two things multiply to give you 8, this could be a 2 and this could be a 4. Or this could be a 1 and an 8, or an 8 and a 1, or a 4 and a 2. Oh, that's the whole list. No, it's not. 16 times 1/2. 32 times 1/4. How many things multiply to give you 8? Endless things. How many things multiply to give you 0? Something times 0. That's the only way. So that's the reason you can't do equals 8. You have to do equals 0. So what do? You're not going to like this problem. How do we make this equal 0? We have to multiply this back out, move the 8 back over with it, and then factor it again. But it's already factored. I know. I wished I could do some other method. So we multiply it back out. It gives me x squared. I'm combining steps. -4x plus 3x gives me -x minus 12. Is that the same? Yeah, sure enough. Equals 8. Move the 8 over by doing -8. Now it's equal to 0. So we have x squared minus x minus 20 equals 0, and refactor. If it factors into the same thing you started with, you did it wrong. XX. Help me factor that, Brett. What adds to give me -1 multiplies to give me -20 would be a negative positive. Good. Everybody good with that? Two things multiply to give you 0, split it. Either x minus 5 is 0 or x plus 4 is 0. Move the 5 over, gives you an answer of x equals 5. Move the 4 over, gives you an answer of x equals -4. Before we go into this, though, just a reminder, if you have to solve one by factoring that has a number out front, if you have to solve one that has a number out front, you have to do the whole bottoms-up factoring. Okay, just remember that. Okay, solving by completing the square, and you might be thinking, I've heard of that completing the square stuff. Yeah, we did it like 2 days ago, right? When we were talking about circles, and we completed the square, that's when we had the x squared plus 6x, and we had to leave the blank, plus y squared minus 4y, and we left a blank equals some number. Okay, that was the process of completing the square. Completing the square can also be used to solve quadratic equations. Okay, if you want to put an asterisk in your notes about this, completing the square is hands down the worst method ever of solving quadratic equations. You probably don't want to do this. Okay, so why am I teaching it? Honestly, 100% honesty, I'm only teaching it so you get more practice at doing stuff like this. That is the only reason, because this is hands down the worst way to solve quadratic equations. I don't know why anybody ever even invented it. Okay, so here we go. With that said, x squared plus 6x plus 7 equals 0. Some people, I've taught it before in the past, some people like it better. I don't know why. Okay, and if you like it better, you don't have to tell me. I'm sorry I was rude about all that. If you like this method, you use it. That's fine. Solving by completing the square. Well, will it factor? What multiplies to give me 7, adds to give me 6, nothing. What does that mean when it will not factor? You're going to have an irrational answer. If it will not factor, your answer is going to look like 2.3849. You're going to have some ugly decimal answer. Okay. Here's how, this is the method of completing the square to find the solution. Step number one, take your C term and move it to the other side, which is actually backwards of what you normally do. I'm serious. If you like it, use it. I don't care. I shouldn't have said all that stuff. Step number two, complete the square. Noah, x squared plus 6x. What do I add to complete that square? 9. Add it to both sides. Again, there's the part I forget. Make sure you put it on both sides. Now that you've completed the square, let's factor it. It'll always factor into half the middle term, so x plus 3 squared equals, go ahead and put those together, equals 2. It's hard to see that. Let me rewrite that. X plus 3 squared equals 2. And look what you have now. It's a problem like we started the day with. Stuff squared equals a number. That makes sense. When you complete the square, you will always have something squared equals some number. So from here on down, it's basic solving equations. To get rid of a square, square root the other side. Now, don't do this. A lot of people, when they're solving by completing the square, will go through that whole process. Then you know what they'll do here? X plus 3 squared. They'll multiply it back out. Okay, think about that. If you multiply x plus 3 times x plus 3, are you not going backwards now? That's pointless. Okay, don't do that. Instead, to get rid of a square, square root the other side. Don't forget the plus and minus. So x plus 3 equals positive or negative root 2. Move the 3 over. X equals negative 3 plus or minus root 2. That's your two answers. Your first answer would be negative 3 plus root 2 if you want a decimal. Your second answer would be negative 3 minus root 2. You might like it. I don't know. That one might have actually been quicker than the quadratic formula we're about to do. Watch me start liking it better. If you want to solve this one by factoring, does this factor? Move the 2 to the end, you get an 8. Is there anything that multiplies to give me negative 8 adds to give me negative 3? No. This one's not factorable. Now that we know it's not factorable, we know we will have an irrational answer. This one's nasty. I'll go ahead and prepare you. Again, hands down the worst method. This is proof of it. This problem will be proof of that. Okay? Step number 1, move your 4 over. I now have 2x squared minus 3x equals 4. Step number 2, and this one's new to you. And this one actually prepares you for conic sections. This one prepares you for ellipses and hyperbolas and parabolas. If there is a number in front of x squared, because think back to circles. When we dealt with circles, there was never a number here. It was always just like x minus 3 squared or x plus 4 squared, y minus 2 squared. There was never a number out front. If there is a number out front, it must be factored. But you're saying to yourself, but I can't factor a 2 out of this because there's a 2 here, but there's not a 2 in that 3. We've lied to you all these years. Yes, there is a 2 in that 3. You can factor a 2 out of 3. Yes, you can. Watch. 2 times x squared minus 2 times what gives you 3x? Don't put 1.5. Okay? If you remember, I told you when you're doing this, when you did that whole half and square and all that, when we did half, I told you to put it over 2. So let me ask you, 2 times what is equal to 3? Well, if I do 3 over 2, do you see what happens to the 2's? They cancel each other out, right? So 2 times 3 halves is equal to 2. Or excuse me, is equal to 3. Again, how do I know that? Because cancel the 2's, multiply it back out, you get negative 3. Again, is this a good way of solving these? No. No. Because now we actually have to complete the square. We have to take half of 3/2 and we have to square it. We have to take half of, this is easy, this part's easy, half of 3/2. Anybody want to share with me what half of 3/2 is? 3/4. And we have to square that, and we have to add it to both sides. Where'd that 9/16 come from? I squared it. Take half of it, you get 3/4. Square that, you get 9/16. Okay, ready to be confused. Did I add 9/16 to the left side of this equation? No. No, I didn't. Yeah, you did. I see it right there. No, I didn't. Notice there is a 2 outside of those parentheses. Multiply that back out. Did I add 9/16 to that side of the equation? No. I added 2 times 9/16 to the left side of the equation. So do I add 9/16 to the right side of the equation? No. You add 2 times 9/16. Whenever you're adding it to both sides, make sure, think about distributing it back out. What did I actually add to that side? I added 9/8. Y'all hate this method yet? But again, the only reason I'm presenting this, well, you have to work one on the test like this. No. Write it down. Keep writing it down as soon as I say it. Keep writing it down, because once we get to conic sections, we will be doing the same set of steps. So I'm presenting it early to where we'll have the entire year to get you ready to do this type of problem. Excuse me. So now I have 2 times parentheses. We factor, this will always factor into half the middle term. Remember me telling you that? Half the middle term squared. We're going to get really good at adding fractions. 4/1 plus 9/8. Common denominator is 8. Multiply top and bottom by 8. 32/8 plus 9/8 is 41/8. We're nearly there, I promise. This will be our last question of the day, obviously. Next step, we've got to get x by itself. Please don't multiply this back out. Okay? You're going back up there and back up there. Don't do it. Next step, let's get rid of our 2. 2 is being multiplied by all this. Let's divide by 2. To divide by 2, you're going to multiply by 1/2. I now have x minus 3/4 squared equals 41/16. Run that around. To get rid of a square, we square root. Gives me x minus 3/4 equals plus or minus. And to square root this, again, I'm splitting it. The square to the top, the square to the bottom. That gives me root 41/4. We're close. One more. Move your 3/4 over, you're done. So x equals negative 3/4 turns into plus 3/4. And I always put it in front of the plus minus. So 3/4 plus or minus root 41/4. You can leave your answer like that, or since you already have common denominators, if you would like to write that as x equals 3 plus and minus the square root of 41/4, that is fine as well. And the reason I went ahead and wrote it that second way, that looks similar to answers that you've gotten previous years. Because tomorrow we'll talk about, there is another method that we can use to solve quadratic equations which we like better than this. That's called the quadratic formula. Anytime that somebody says that they don't like the quadratic formula, I'm going to slap them, because if not, we're going to have to work it this way. Every one of them. Look at that answer. Remember the whole negative b plus or minus the square root of b squared minus 4ac over 2a? Does that not look like those type answers? Okay, this is actually where the quadratic formula was born from, was this process of solving.